One more minute. A Black Ops sniper lies on top of a skyscraper, aiming his rifle. His target? A man who will emerge from under this bridge. The sniper comes from the future and is tasked with eliminating a man from the past. He doesn't know why. His heart rate increases. His hands are sweating. His breathing quickens. He's a very experienced sniper, the best in his division. But this time, somehow everything feels different, because this shot will not only decide one life, but the future of all humanity. 15 seconds left. There he is. He exhales one last time and takes aim at the victim's head.
Target acquired. Fire when ready.
What he doesn't know yet, the man he's aiming at is himself. Stories like this demonstrate the biggest problem with time travel. What happens if we travel back in time and erase our former selves or one of our ancestors? In the exact moment we prevent our own existence, we could never travel back in time to do the same. This seemingly unsolvable dilemma is known as the grandfather paradox. And it's just one of many paradoxes that make time travel so dangerous. But this raises two even bigger questions. What happens to the victim now? And what happens to the sniper? Can both even exist? Or did they just wipe each other out? Before we can answer that, we need to ask one even deeper question. What is time anyway? And if we start changing it, will that ultimately destroy humanity? To find out, let's solve the case of time. According to Isaac Newton, every event has a fixed place on the timeline. According to him, time moves linearly and steadily forward, just like a river. It seems impossible to speed up or turn back. You are destined to just drift with the current. Additionally, past events can never be undone, and causes always precede their effects. This idea of a universal clock that passes at the same time for everyone was refuted in 1905. The person responsible is a young up-and-coming physicist specializing in the field of theoretical physics. His name is Albert Einstein, and his special theory of relativity proves that time is relative. Einstein discovered that time passes at different speeds for moving and stationary bodies. As an explanation, he refers to the speed of light in his theory, the highest speed possible in our universe. Light travels approximately 300,000 kilometers per second, orbiting the Earth 7.5 times in this time. And the closer a moving body approaches the speed of light, the slower time passes for him. However, only relatively speaking, because for all other stationary bodies, time appears to pass faster. But how can that be? Einstein showed that space and time do not exist independently of each other. In 1908, Hermann Minkowski took up this idea and developed it further. The result of years of research was the so-called block universe. Let's now take a look at this box. It can be represented by a combination of the vectors length, width and height, the three known dimensions of space. Minkowski was now able to prove that time actually represents a fourth dimension in space. The problem, mathematically speaking, all four axes must be at a 90-degree angle to each other, and that's simply impossible. Because humans cannot imagine a four-dimensional space, he chose a surprisingly simple solution. He treated space as if it were only two-dimensional. Then, he introduced time as a new axis, which is now at a 90-degree angle to the other two axes. The result is a block consisting of space and time, called spacetime. Now let's say we have 2 points in this space. When the red ball moves through space, it also moves through the block, and thus through spacetime. This means that time passes differently for the two balls, and this depends on how they move through the block in relation to each other. But this also means that the balls don't share the exact same present, because each present is just a slice in spacetime, a snapshot of a precise moment in time. And this slice moves depending on how fast a body is moving or where it is located. This means that there can be multiple present levels simultaneously, and yet all are equally real. This is exactly the kind of level we call spacetime in the rest of the video. When it deforms, rotates or changes, it formally always happens within the block, even if we don't show it. Okay, that was a lot, but it's also the basis for everything that's to come. It is precisely this property of curved spacetime that allows for something that humans have always dreamed of: time travel. What exactly could it look like? In theory, there are 3 possibilities. 2 take us into the future, but only 1 can take us into the past. Option 1 is gravity. Time doesn't move at the same speed everywhere. We've understood that by now. But imagine you're an astronaut. You and your best friend have been sent to explore a black hole. While you float at a safe distance in your spaceship, your friend moves slowly towards it. For you, time passes quite normally, because where you are, spacetime is barely curved. But as you watch your friend approaching the black hole, he seems to be moving slower and slower. To him, everything feels completely normal. But the closer he gets to the black hole, the more spacetime is curved around him. And the more his time slows down from your perspective. The movie Interstellar shows exactly this. Cooper, the main character, explores a planet where 1 hour is equivalent to 7 years on Earth. At the end of the movie, he's 124 years old relatively speaking, even though he was only in space for 6 months. This so-called gravitational time dilation means that he has actually traveled into the future, and that without the use of a time machine. The second possibility is based on Einstein's special theory of relativity, which focuses heavily on the speed of light. Imagine you're in your spaceship, flying to a distant planet and back at 99.99% of the speed of light. This journey will take you somewhere around 6 months. But when you return, you'll find a different world, because you will arrive in the year 3000. We already know why this works. The closer you get to the speed of light, the slower time passes. And that actually means you've traveled through time, through pure speed. Those are the 2 ways to travel into the future. But now things get really interesting. Because for the journey in the past, so the classic time travel as we know it from Back to the Future, something else is needed. A closed time-like curve. This model was developed in the 1930s by a physicist called Willem Jacob van Stackum. We won't explain the exact physics here, but imagine the following. You're walking along a path that goes around in a circle. You keep walking, but at some point you end up back at your starting point, without ever turning around. Now imagine that this path isn't through space, but through time. This means you move forward, as always, but at some point you end up back in the past exactly where you started. So you travel back in time, to the exact point in the block universe where you were. To create such a loop, there are 2 specific ways. For the first one, imagine a sheet of paper. If you want to go from point A to point B, you have to walk across the paper. But what if you fold the paper and stick a pen through both points? Absolutely right, you've just created a shortcut. A wormhole works similarly. It's a tunnel that connects 2 points in spacetime. It occurs because time stretches near large masses, and spacetime becomes curved. The more mass, the greater the curvature. At extreme curvature, a tunnel forms, the so-called wormhole. Theoretically, you could travel through this tunnel to another time, because you would reappear at a different point in spacetime. To create a stable wormhole, you would need exotic matter with negative energy density. Whether such matter can even exist is controversial, just like the existence of a wormhole, which science is convinced of but has never been able to prove. A collapse of the tunnel would release energy that could potentially destroy our whole universe in the fraction of a second. Time travelers inside the wormhole would be trapped between times, in a vacuum from which they could never escape. The second option is by Frank Tipler, who solved the problem of time travel in 1970 using the Tipler cylinder. This cylinder would have to have the mass of 10 suns to ensure a sufficiently strong curvature of spacetime. At the same time, it must rotate at least a few billion revolutions per minute. So the implementation of this model is currently impossible, because in addition to the immense mass, the cylinder would have to have an almost infinite length. But theoretically, it could work, because the extreme rapid rotation causes a curvature of spacetime, and thus the formation of a closed time-like curve, which allows time travel into the future and the past. So time travel is theoretically possible, but only through as yet unexplored possibilities, such as travel at the speed of light, wormholes, and extreme gravity, like that near a black hole. But just because time travel might be possible from a physical point of view, what does it look like from a purely logical point of view? We've already learned about the grandfather paradox. In the original, you travel back in time to prevent your grandparents from meeting each other. That means, conversely, that you aren't born at all and can't travel back in time either. But there are also other problems that seemingly make time travel impossible and could destroy us. For example, the information paradox. Imagine, you travel to the future and find a book titled The Complete History of the 21st Century. You take it back to your time and study it. The book contains knowledge that someone must have written down at some point. But where did this knowledge originally come from? The information has no origin. It exists in an endless loop. What if these information are false? Or perhaps even intentionally manipulated? Based on it, we could make catastrophic decisions that would plunge humanity into ruin. Another problem is the bootstrap paradox. Imagine you wake up from a coma. You have no idea where you are or what year it is. But you find a letter next to you with 2 words in it. Study medicine. You follow the advice and become a successful doctor. You keep the letter as a memento. Science advances and you travel through time to help people in the past. There, you operate on a young man who was in a serious car accident. You save his life, but can't prevent him from falling into a coma. That young man is you. You place the letter with the word study medicine next to him, and the cycle begins again. Who wrote this letter? Not you, you were in a coma. But your future self has always had it too. So that means no one wrote the letter. It exists only in a temporal loop without a beginning or end. But the most frightening paradox is undoubtedly the consistency problem. Let's assume that reality couldn't change drastically through time travel. Any attempt to change the past would somehow cause it to occur as it should anyway. But how does that work? Do we have no free will and are we simply at the mercy of everything? Or is the universe itself perhaps structured in such a way that certain events are inevitable? An attempt to break this determinism would mean the collapse of our entire reality, a tearing apart of the space-time structure, and with it, the end of humanity. But science has developed various models to resolve these paradoxes. For example, the many-world theory. It states that every time we travel back in time and change something, we create a parallel universe. This means when our sniper from the beginning of the story shoots his former self, this former self dies in a parallel universe. But in his own universe, the sniper continues to exist. There are no more paradoxes because every change creates a new universe that exists independently of the original, which admittedly still sounds somewhat paradoxical. These parallel universes could, however, be connected. This is best explained with the following example. There are 2 particles that interact with each other. Quantum mechanics assumes that these particles now become entangled. This means that even if they are later far apart, they will still remain connected in a special way. If this connection can exist in our universe, then theoretically it could also exist between different universes. The problem is, if one universe collapses, a domino effect would occur. The released energy would reach through the entire multiverse via quantum entanglements and completely destroy it. The second common theory of consistent timelines, according to Novikov, states that the universe itself remains consistent, and therefore only allows time travel that doesn't create paradoxes. In our example, the sniper was always destined to travel back in time and try to kill his former self, but something will stop him. Perhaps his weapon malfunctions at a crucial moment. History cannot change, it is already completely determined, including all time travel. According to Novikov, there is therefore only one consistent timeline which completely roots out the existence of parallel universes. And whether that's really the case is another question. Despite all the dangers and contradictions, scientists are confident that time travel will be possible one day. A study by the research team led by Peter Szymanski from the University of Vienna and Miguel Navasquez from the Institute for Quantum Optics and Quantum Information shows that individual photons can time travel. This means the photon was successfully moved into a past or future state. Szymanski emphasizes that such quantum leaps are also possible for larger particles. However, research is still years away from a breakthrough. Whether this will ever occur is also questionable. But let's suppose time travel were actually possible at some point. What would that mean for humanity? Imagine you travel back in time and make a small decision. You stop a stranger on the street to ask for directions. This stranger misses his bus as a result and doesn't die in a bus accident that occurs later. He lives on, starts a family, and his descendants change the course of history. Who is responsible for these massive changes? You as a time traveler? Or chance? And who decides which changes to the past should be allowed? And even more importantly, who claims that an alternative future is better than the actual present? And if time travel were actually possible, who would have access to this technology? Only governments and the military? Only the rich and powerful? Or all people? Control over time means ultimate power. And as we know, power can be abused. This is where the temporal weapon paradox comes into play. It explains that time travel is only used for military purposes. For example, eliminating an enemy nation before it can cause damage. An arms race through time would completely destabilize and ultimately destroy the entire structure of our space-time. Furthermore, if the future is already determined and we can visit it, do we still have free will? Or is everything already predetermined? If you know you're going to have a serious accident in 5 years, can you prevent it? Or are you powerless to change your fate? The Hitler dilemma perfectly illustrates these ethical conflicts. Would you kill Hitler if he could travel back in time? At first glance, the answer seems simple. Yes, of course. But what would the consequences be like? Perhaps someone worse would take his place. Nazi Germany would win the Second World War and rule the world. And most importantly, who gives us the right as individuals to decide the course of history? What does this mean for our sniper at the beginning? If he shoots and hits, it has dramatic consequences. In the exact moment he eliminates himself, a parallel universe forms. And these destabilize each other until one final shot can lead to the collapse of the multiverse. At the same time, he erases the course of his journey. He no longer exists to fire the shot, which means he will never travel back in time. Therefore, he can never be eliminated. Another possibility is that the sniper fails. He misses the shot, which is what prompted his younger self to join the military, because he can't live with this trauma. A few years later, he becomes part of a secret research project and is tasked with eliminating a target in the past. The timeline remains consistent, there is no way to change it. Each of these options is frightening, because conversely, it could wipe out humanity. But that doesn't seem to bother us. As humans, we have always challenged the limits of what is possible. We have visited the moon, split atoms, and invented the internet and artificial intelligence. However, controlling time would be our greatest and most dangerous conquest. A nuclear war would kill billions, but a single failed time jump could not only wipe out humanity, it would ensure that we have never even existed. Perhaps it's no coincidence that we have never met time travelers from the future before. Perhaps every civilization capable of time travel has been wiped out. Although the idea of controlling time may be fascinating, time travel is no progress. It is the end.